everyone. Today we are going to discuss about the day-to-day researches for the new compound semiconductors have paved the way for development of present electronic world. So the introduction goes on like the semiconductor industry appears to be at or near an inflection point within its history. It is facing two discontinuities simultaneously. The industry has to face the physical limits of existing semiconductor materials. At the same time, new applications are driving demand for even smaller, lighter, and more powerful semiconductors. Then what is mean by this compound semiconductors? It has three properties: the power, speed, and light. Then their unique properties mean that compound semiconductors are finding increasingly diverse applications such as in electric vehicles and 5G chips. That electric vehicles range extension requires a highly efficient and gallium nitride chips provide high speed data links for 5G. So this is that chip, compound semiconductor chip, you can see in that slide. Then the current applications of compound semiconductors and research focus. It is the compound semiconductors has become an essential component of many sectors, and technological institutions all around the world have invested much in research and development. It is also used in the microwave epitaxial material business for technological advancement and appliances. Then applications of compound semiconductors. So first application is it is used in the microsystems. So the microsystems have become an emerging technology because of their unique intrinsic properties, which offer a number of materials based advantages for optoelectronic and sensing applications. It is this is a cantilever which we already discussed, like it is used in the application to fabricate the cantilever, and it is a wave guide switches. So it's a cantilever that's building. Here it is another, this is one known as wave guide switches, this is cantilever. So the compound semiconductor in microsystems used to fabricate this cantilever and wave guide switches and so on. Then optoelectronics. So it has a capabilities in optoelectronics that cannot be obtained from silicon or germanium. One of the challenges of compound semiconductor is the presence of surface defects that introduce states within the band gap, leading to surface charge carrier recombination. The first reported organic self-assembled monolayer on any semiconductor surface was a gallium arsenide. Then it is the optoelectronic devices which use compound semiconductors. So this is a laser diode, photodiode, then LED display. The LED means light emitting diode, then it's a solar sensor. Then the compound semiconductor is also used in the thin film solar cells. It's thin film solar cells which are flexible and extensible. Then some characteristics of compound semiconductors, like high speed. It has high speed operation because due to the high electron mobility. Then it has light emission, both visible and infrared light for lasers and LEDs. Then sensitivity to magnetism, then resistance to heat and radiation, low voltage. Then it have a ability to generate the high frequency signal. Then we reach the conclusion, it goes on. So the advantages of compound semiconductors such as gallium arsenide and indium phosphide and mercury cadmium telluride for use in optoelectronic devices and in ultra high speed or high frequency electronic devices are well established. In these ways, the day-to-day researchers for new compound semiconductors have paved the way for the development of the present electronic world. Thank you.